An AI agent can look impressive in a demo and still be nowhere near ready for a job. Give it one task. Open a browser, find a record, fill a form, call a tool, write a file. It may do fine. Maybe it passes the benchmark. Maybe the trajectory even looks clean. But a job is not one clean task. A job has state. It has decisions that constrain tomorrow. It has feedback that arrives late. It has partial failures that do not look catastrophic at first, but quietly accumulate until the system is worse than when the agent started. That is the gap these new long-horizon agent benchmarks are trying to expose. The question is no longer just, can an agent complete a task? The question is, can it stay coherent long enough to be trusted? In other words, your AI agent just got a probation period. Long-term coherence sounds abstract, but the idea is simple. A coherent agent keeps pursuing the same objective across time, while updating its decisions as evidence changes. It does not just remember words in a chat window. It understands that the environment has state, that previous actions matter, and that delayed outcomes should change future behavior. That is a very different problem from a bounded tool use task. In a bounded task, the agent can often succeed by finding the next obvious action. Search here, click there, run this command, submit the answer. In a long-running environment, the agent's earlier choices become part of the environment. If it spends too much cash, it has less liquidity later. If it chooses a bad supplier, the rating hit may not show up for days. If it overreacts to a temporary signal, it may damage the strategy it was supposed to preserve. The context window is not the source of truth. The world is. That is the uncomfortable part for agent builders. You can have a model with a large context window and still have poor long-term coherence, because the challenge is not just recalling facts. It is maintaining a policy under persistent state and delayed feedback. Merchant Bench is a clean example of this shift. Instead of asking an agent to complete a short e-commerce task, Merchant Bench puts the agent in charge of a seller-side store for 365 simulated days. The agent has to source products, control listings and prices, manage cash flow, monitor supplier states, and react to downstream order outcomes. The environment is grounded in 98,843 real e-commerce product records, and the agent interacts through 26 tools. That matters because e-commerce creates a natural long-horizon trap. Some signals are immediate. A supplier changes availability. A product looks promising. Cash is available right now. Other signals are delayed. Orders move through fulfillment, delivery, settlement, and after-sales outcomes. A decision that looked profitable can later produce returns, complaints, rating damage, or liquidity pressure. So the benchmark is not just measuring whether the model can call tools, it is measuring whether the model can maintain a coherent operating strategy while reality pushes back at different speeds. The paper evaluates 8 LLMs under 2 agent frameworks in 48 runs, each spanning 365 simulated days. The headline result is blunt. The best LLM configuration reaches only 27.3% of the mean final net assets achieved by human participants. That number should not be read as agents are useless. It should be read as short-horizon competence does not automatically become long-horizon operations. The agent has to keep a portfolio of decisions alive. It has to revisit earlier choices. It has to avoid local optimization that starves the store later. It has to notice when delayed evidence means the strategy should change. That is much closer to a job than a benchmark puzzle. RealReplicaBench approaches the same problem from another angle. Instead of a single year-long store simulation, it builds stateful replicas of business workflows. The repository describes 107 tasks across browser operations, command line tools, files, API and MCP, workflows, documents, spreadsheets, supplier analysis, product publishing, logistics, and commerce operations. The task surface is deliberately mixed: 53 CLI tasks, 28 browser tasks, 16 file tasks, and 10 API or MCP tasks. Some are text-only. Some require browser text interaction. Some require vision. The point is not that every replica is the real service. The point is reproducibility. Agents need environments where they can change state, leave artifacts, produce logs, and be judged against verifiable outcomes. That is a big difference from evaluating an agent on a static prompt or a fake web page with one hidden answer. In a stateful replica, the agent has to operate the system. It may need to research, edit a spreadsheet, change a mock storefront, book a logistics workflow, or call an API. And the benchmark can preserve the trajectory, configuration, logs, artifacts, verifier results, and container metadata. That gives evaluators something closer to an audit trail. This is the direction serious agent evaluation has to go. Not just, did the final answer look right, but what state did the agent create, and can we reproduce the run? The failure mode here is subtle. It is tempting to say the model just needs more intelligence. Sometimes that is true, but long-horizon failures are often control failures, state failures, and feedback failures. The first problem is that the environment remembers more reliably than the agent does. A database row changed by the agent is still changed tomorrow. A bad price is still live tomorrow. A missing document is still missing tomorrow. The second problem is delayed credit assignment. If a decision causes damage later, the agent has to connect the later outcome back to the earlier action. That is hard even for humans, and it is especially hard for systems optimized around immediate next step success. The third problem is compounding local choices. A short-term fix may look reasonable in isolation, but if every step optimizes for the next visible metric, the whole trajectory can drift away from the actual goal. This is why long context is not the same as memory, and memory is not the same as operational coherence. A useful worker does not just remember the past, it uses the past to maintain a stable objective under changing conditions. The practical lesson is straightforward. Agents should earn autonomy gradually. Do not give a model production permissions because it passed a short benchmark or completed a flashy demo. Put it through a probation period. Start with shadow mode. Let it recommend actions without executing them. Then give it narrow permissions in a sandbox. Measure not just task completion, but state quality after many steps. Then test delayed feedback. Did it notice the downstream consequences of earlier decisions? Did it revise the strategy? Or did it keep repeating a locally plausible mistake? Then expand the trust boundary. This is how agent platforms should think about deployment. Not a binary switch between assistant and autonomous worker, but a permission ladder backed by long-horizon evaluation. The stack needs durable logs, explicit policies, state inspection, rollback paths, and evaluation environments that resemble the work you actually want the agent to do. Merchant Bench and RealReplicaBench are early examples of that evaluation layer. They are not the final answer, but they point in the right direction. If agents are going to become coworkers, they need performance reviews. The next generation of agent benchmarks will look less like quizzes and more like job trials. They will test whether an agent can preserve an objective, manage state, adapt to delayed evidence, and avoid making the system quietly worse over time. That is the real bar for agentic software. Passing the demo is not enough. The agent has to survive the job.